Sonar, Sound Waves, and Reflection by Joseph Quintain.
What is sonar? Sonar is a navigation and ranging tool, and it uses sound waves to detect and locate objects underwater to help people determine where things are that we can't see.
The origins of sonar. Sonar traces its origins all the way back to the 15th century in Leonardo da Vinci, with the famous painter using a tube in the water to listen for nearby ships. The idea of using sound to detect things underwater is an idea as old as time that has only recently been turned into technology. The first sonar technology was developed in the early 1900s by commercial ship companies that were looking to avoid icebergs, but it soon became more widespread and used by militaries, especially during World War I, to try and detect submarines, and it was also used by submarines to detect ships on the surface.
So who uses sonar? Kind of what Hank went over, but submarines used by the Navy to detect enemy vessels, fishing boats. They can detect school of fish to help people know where to fish. And then scientific research, sonar can help map out the seafloor. And then recreational boats can use sonar to make sure that they're in deep enough water, so their fins and rudders don't break off when they go too shallow.
The impacts of sonar. So sonar has many different purposes, and it's been used by many different people over time. As mentioned before, sonar has been used for scientific, military, recreational, and safety purposes. Sonar has allowed people to have a deeper understanding of the world's oceans, and it has allowed them to map out things that were undetectable before then.
So the overall greater purpose of sonar was to enable humans to understand, navigate, and operate safely in the ocean. And sonar serves as our eyes and ears underwater, detecting what we can't see.
So why sonar? So why is sound waves, especially in sonar, used instead of just light waves, like turning on a light to try and see it underwater? So sonar uses sound waves to identify things below the surface. Sound waves are used instead of light waves because sound waves travel faster in water. So water is like a denser medium than air. And because sound waves are a longitudinal wave as compared to light waves, which are transverse waves, sound waves travel faster underwater than light waves do. They also travel further. So they can detect things at a further distance, and also it can be done more quickly than if you were to just turn on a big light underwater, and that's why sonar uses sound.
So how sonar works? So sonar has a transmitter send out sound waves into the water, and then the sound waves will reflect off the object that it's trying to detect, how far away it is from. And the sound waves comes back to the receiver, and the receiver picks up this reflected sound wave, and then the system tracks it, keeps track of the sound that between when it's sent and when it comes back, so it detects. It uses an equation to measure how far it is. That's in a later slide.
Okay, so the science of sonar, reflection. So the basic wave behavior that sonar is based on is reflection. So reflection is a wave bouncing off of something when it hits a surface or an obstacle that it can't go through. This occurs with light, sound, and water waves. And so what we see here is the incident wave, and then the reflected wave bouncing back.
Okay, so first, there's definitions of the vocab and reflection. So first we have the incident wave. This is the wave that it's the initial wave that hits the surface that it's going to reflect off of. And the reflected wave is what actually reflects from the surface. And then normal is a line that goes straight down parallel to the surface from where the incident wave made contact with the surface. And then the angle of incidence is basically the angle that the incident wave made contact compared to the normal of the surface. And the angle of reflection is the angle that it goes off away from the surface. And then the law of reflection tells us that the angle of incidence and the angle of reflection, they have to be equal, so then we get like symmetry between the incident wave and the reflected wave.
Yeah, and just really fast, like in like the case of like sonar, like the incident wave is like the pulse that's sent out by like the boat or the submarine or whatever, and then the reflected wave is the wave that bounces off of the object and goes back to the emitter. Okay, so a fixed end is a boundary that does not move, which causes the wave to reflect. So in the case of sonar, that'd be any object that it can't go through, it will bounce off, and that's how, basically how sonar can work. And then a free end is a boundary that can move, causing the wave not to invert and stay normal. Reflection and inversion with a changing medium. When a wave moves from one medium to another, it can reflect. It may invert depending on the medium's properties. And then transmission is when a wave passes through a material or boundary and continues traveling into a new medium. Waves reflect more when the angle of incidence is larger.
So how sonar calculates distance, this is the equation that it uses when it tracks the speed of sound. I mean not speed of sound, the time that it takes to come back. So the speed of sound is 1500 meters per second, but it can change a little based on the temperature, how salty the water is, and the water pressure, because those can all change the medium of the water, and sonar keeps track of that. So it's really accurate about how far stuff is and just how it calculates the ocean floor and everything that it can be used for. And then the equation is divided by 2 because we only want to know one way. We don't want to know both ways, there and back. Well, that's what it calculates. So it divides by 2 to know how far it is away from the ship or submarine.
Okay, and then this is a video that demonstrates very basically how sonar works. So hopefully you can see that. Okay, so ways to improve sonar. Finally, sonar is become super advanced now, but it's not perfect, and some of the technology using it can be a little older depending on when it was developed. But ways that sonar can be improved. Sonar can be used with AI to turn the traditional 2D sonar picture to a 3D picture. So you can see here on the pictures, this is an example of what sonar usually gives you. It usually just gives you a 2D layout, but it's harder to tell the depth of things when there's something like that. So if there's a more mountainous terrain, as there sometimes is on the bottom of the ocean, it can't really tell how high things are or how low things are. It kind of struggles with that. So it can use AI to kind of fill in those gaps, to kind of interpret the data in a way that humans can't really, but the machine isn't designed to. So it can use artificial intelligence to fill in those gaps to give kind of a more complete actual picture that's easier to interpret and easier to use. And this can help us visualize the ocean floor better as humans are trying to understand what all is in all the oceans. So that's it.